Okay, so here is the problem. O is the origin and points A, x1, y1 and B, x2, y2 are such that A is in the first quadrant, B is in the second quadrant with mod x1 less than mod y1, mod x2 greater than mod y2 and x1, x2 plus y1, y2 greater than 0. If the lines joining the origin to A and B have a joint equation of ax squared plus 2hxy plus by squared is equal to 0, where A is positive, we have to decide whether h is 0, negative, positive, or whether we are not able to say anything. So let's first take a look here. Let's get what we can out of the statements in the problem. We have given that A is in the first quadrant. Automatically that tells us that x1 and y1 are both positive. We are also told that mod x1 is less than mod y1. Therefore tan theta 1, which is y1 by x1, will be greater than 1. And so theta 1 will be greater than pi by 4. Since this is a first quadrant angle, we can conclude that theta 1 lies between pi by 4 and pi by 2. B is given to be in the second quadrant. That means that x2 is negative, y2 is positive. Now we are given also that mod x2 is greater than mod y2, which means that tan theta 2, which is y2 by x2, will be greater than minus 1. So now that tells us that theta 2 is greater than 3 pi by 4, and since it's a second quadrant angle, we get that theta 2 lies between 3 pi by 4 and pi. So now these are the two things that we have. Theta 1 lies between pi by 4 and pi by 2. Theta 2 lies between 3 pi by 4 and pi. Adding them, we can see that theta 1 plus theta 2 lies between pi and 3 pi by 2. In other words, theta 1 plus theta 2 is a third quadrant angle. So now tan of theta 2 plus theta 1 is simply tan theta 2 plus tan theta 1 divided by 1 minus tan theta 1 tan theta 2. Since this is a third quadrant angle, this is greater than 0. Tan theta 2 we just realized was y2 by x2. Tan theta 1 is y1 by x1. So we get this expression here. Multiplying numerator and denominator by x1, x2, we get this expression x1, y2 plus x2, y1 divided by x1, x2 minus y1, y2 greater than 0. So let's hold on to that. Now again, going back, A is in the first quadrant, B is in the second quadrant. So we have x1, y1, y2 positive and x2 negative. Automatically we know that x1, x2 will be negative, y1, y2 is positive. Now we are given that x1, x2 plus y1, y2 is greater than 0. What that means is, since x1, x2 is a negative number, it means that mod of y1, y2 must be greater than mod of x1, x2. And that means that when we add these, mod of x1, x2 plus y1, y2 will be less than mod of x1, x2. So now subtracting 2y1, y2, yeah, so we have x1, x2 minus y1, y2, that will be equal to x1, x2 plus y1, y2 minus 2y1, y2, that will be negative. But remember what we had earlier? This is the earlier expression, yeah, and we have been given that the denominator, now we've realized that the denominator is negative. If the whole expression is positive, that means the numerator must be negative as well. Now the equation of OA is y1x minus x1y equal to 0. Equation of OB is y2x minus x2y is equal to 0. Therefore the joint equation of OA and OB will be the product of the two expressions. Expanding, we get y1 y2 into x squared minus of x1 y2 plus x2 y1 times xy plus x1 x2 times y squared is equal to 0. And we are going to compare this with ax squared plus 2hxy plus by squared. That gives us that a is y1 y2, which is greater than 0 as specified. 2h will be minus x1 y2 plus x2 y1, and b is x1 x2. Now consider 2h. Yeah, 2h is minus x1 y2 plus x2 y1. We already have that x1 y2 plus x2 y1 is negative, and therefore we can conclude that h is positive.